So the main thing is, I thought I will talk to you about what is the career opportunities for chemistry graduates, what they can do for that, what are all the various avenues open for them. Apart from any computer trained people going into IT departments, what you can do specifically with chemistry. So only chemistry. So that kind of things we are going to look at. And how are you going to prepare for that? Are you ready for taking up any job at this stage? Or after getting your degree? How ready are you to take up a position, a job in any industry? Whatever industries are there, I will tell you. Are you ready? So how do you make yourself prepared for doing that kind of a job and successfully? It is not that you enter into a job and then do something average. No. You need to excel in your job and come up. That is the motto. That is your aim. That's what you should do also. Now, I thought I will go through my own experience as a researcher. Now, out of many available things for chemists, one of the departments, one of the areas for career is, have you all decided what kind of a job you would like to do? Anybody? What kind of a job you want to do?
Hey, please tell me. He is assuming that you guys know English. Not please tell it.
இல்லைன்னா சொல்லுமா, தமிழே கேட்குறேன். நீங்கள் என்ன ஜாப் பண்ணணும்னு பார்க்குறீங்க? எந்த கம்பெனியில் இல்லை எந்த கெமிஸ்ட்ரியை பண்ணணும்னு பார்க்குறீங்க? கெமிஸ்ட்ரின்னு பார்த்தாக்கா இது ஜஸ்ட் நம்ம இங்கே படிக்கிற கெமிஸ்ட்ரி வந்து ஒரு பேக்ரவுண்டு உங்களை ப்ரிப்பேர் பண்ணுறதுக்கு. என்ன கெமிக்கல்ஸ்னால் என்ன, எலிமெண்ட்ஸ் என்ன, இதெல்லாம் தான் நம்ம தெரிஞ்சுக்கிறோம். அதெல்லாம் எப்படி ரியாக்ட் பண்ணோம் இப்படிலாம் பார்த்துக்கிறோம். பட் ஃபைனலி வாட் இஸ் த கெமிஸ்ட்ரி யூ ஆர் கோயிங் டு ப்ராக்டிஸ் ஆஃப்டர் யுவர் டிகிரி? ஸோ தட் இஸ் வாட் ஹவ் யூ டிசைடட் என்ன பண்ணணுன்ட்டு தெரியுமா உங்களுக்கு? ஓகே, சரி, தேங்க்யூ சார். So if you have not decided, you will have to find out what is that you are going to be. Maybe after this lecture you can probably start looking at, exploring what is your interest, which area you are interested, and which type of chemistry you want to do, and things like that. So that is more important before you prepare yourself for the career. You need to do that. MSc is only a degree where you are learning the fundamentals. So that is why I chose this topic, and also this is a chemical society inauguration. I thought this would be more appropriate for the students. Career in chemistry, preparation and growth. How do you prepare for your career? Now, how do you grow in your career? It is not just entering. Then you have to grow, right? You can't be stagnating in one position. So how do you grow? So that is the kind of talk I am going to give today. And the purpose is to enumerate the opportunities in chemistry. What are all the opportunities available for chemistry, chemists, and how do we choose for our own career? And experiences in research. See, I have chosen research as my career, and so I will talk about my experiences. How did I achieve this kind of position or career growth myself, and how I can integrate all the experiences and tackle any problem, any of the requirements in different areas, not just in chemistry, but different areas. So what are all the areas? We will discuss about that one. And also a small talk about a discussion on skill development needs for different areas. What are the skills that you need if you want to go for this particular job? What people expect? what your employer wants you to know. So all those kinds of things you will have to address. So look at chemistry, the career options. One is university professor. In those days, that was the goal. And later on, researcher, university or industry or government labs. That's another area where chemistry can help you. And then PhD in physical or life sciences. Suppose you want to go for research, you need to go for PhD. PhD in which area? Physical science or life sciences. And you can become a lawyer. How a chemist can become a lawyer? There are a lot of litigations, a lot of things coming up, right? So unless you know something about the chemistry and the issues, you will not be in a position to argue out. You might have heard about what happened in a big company, Herbal company. Their claims, they made some claims, and the court has restricted, or rather they have named them for not pronouncing that kind of claims. So for defending all those things, you need to know something as a lawyer, if you are going to go as a lawyer. And what you can do as a lawyer with chemistry is, you can go for patent. If somebody is going to patent their work, you can guide them and do that kind of a patenting the research work. So a lot of things are there here, so many areas where you can get into with chemistry. And what next after your MSc? What next? You can become a chemical engineer, laboratory analytical chemist. That's a major thing which people want to do, analysis. And they want to do analysis and they want to go as an analytical chemist. Or in a pharmaceutical industry where you can do some kind of drug development or synthesize molecules and produce them. Active pharmaceutical intermediates, so many things. A lot of things are required for chemists. And you can see that Syngene, when we were in Spic Science Foundation, started off in a small lab like this. And they didn't have even NMR at that time. They used to send the samples to me and I analyzed. And nowadays you have the email and the WhatsApp, you can send the results. But in those days it was not there. I used to send a fax to them, send the results through fax. And they were very happy that they were able to get the results in the evening. So, and they were able to proceed in their projects. So, that kind of big requirement in synthesis, and they have started expanding, and now it is a very big area, mind-boggling. If you go to Bangalore and see the Syngene, various buildings, and 22 buildings are there, and housing around 5,000 employees, chemists, to do the synthesis. And also you have this specialty chemicals and fine chemicals, and petrochemicals and plastics. Pesticides and agrochemicals is another very major area. One of our alumni here, Dr. Panchaksharam, responsible for this hall, he worked in a pesticide company and he has done pretty well. And fertilizers, dyes, pigments, paints, varnishes, all these are the various industries or places where chemistry is being used. And you can get interested in any of these areas and then start developing your career. And I can give a lot of examples of my own students and others who are in different companies. Now, my own personal experience, I just wanted to talk about this. My interest was in research, not on other pharmaceuticals and all those things. I wanted to do research. How did I build up my career? Now it is more driven by passion and curiosity than by any planning. I didn't plan. I did my MSc here, and at that time all my staff used to tell me, Narasimhan, you are a rank product. You should get first rank, university rank. But somehow or other, I don't know what happened. We had all 6 exams continuously from Monday to Saturday, and even practicals, all 6 exams. In those days, the system was, even if you have an arrear, you have to write entire exams again, not just that arrear paper alone. So that was the system in those days. So I don't know whether those things were boggling my mind or something. I lost my first rank by 1 mark. I was talking to Professor, I just met him. I asked him, what's the meaning? I asked first rank, first mark, first class. He said, no, second. So I was very upset. But anyway, he came and told me, Narasimhan, don't bother, you can do research. So I also wanted to, nullify that effect of second class in my career, a blemish, which I don't want. So what is the way? You go to the higher degree. So I wanted to do PhD. So when I wanted to do PhD, there was a position available here for a CSIR fellow. So professor said, would you like to take that? I said, okay, sir, I will take that. Then he conducted an interview and all those things and chose me. And then I came when Professor Sundaram was there. I told him, Sundaram called me and said, Narasimhan, this is our 3-year project. If you join, you cannot leave. So there are a lot of issues. If you get some other place also, you cannot go. You have to be here. So decide, think and decide. When I told him, sir, I have decided. So what? No, I am going to do PhD, joining. But can I finish it in 3 years? He said, oh yes, sure. You can complete it in 3 years. So that was the, motivation thing for me. I joined, and then professor used to come around 11 o'clock to the research lab. And one day, after 1.5 months, he didn't tell me anything. He came and said, Narasimhan, you start working on oxidation of hydrocarbons using transition metal ions. That's your project. You go ahead and start working on that. So then the next thing I met him was after I prepared a few publications. So until such time I didn't go and meet him. I just started doing my work. And during research time, the passion was so much that we used to stay overnight in that lab. And that library had a very big table. So we used to sleep on the table overnight, and I used to do all the reactions and also help my seniors, SR and so many people. And I could go along with that one. What is important in my research career is PhD career, not the other one, PhD. Usually here people used to do solvent effect, that is ester hydrolysis or hydrolysis studies. So that was a major area which professor was doing. And another project was on chromium 6 oxidations. So I was the one who was given this hydrocarbon oxidation, and I was doing that one. And we used to send publications for International Journal of Chemical Kinetics and all. So when I sent one paper based on fluorine, you know what is the fluorine structure? Not element fluorine, but organic chemistry, fluorine. So that fluorine oxidation with vanadium. So when I did that one, I published. I sent a publication, and faithfully I said that this oxidation product was, it is giving fluorinone as a product, and we get an yield of 70%. So I thought, okay, 70% people will agree. But that referee, he refused to agree that thing. He said, what is that remaining 30%? You have to say what is that remaining 30%, otherwise you cannot publish. So then it took me 6 months to work on it, and Dr. Ramani was the pool officer at the time, and he came and he helped me. So we did a preparative thin layer chromatography, and isolated that product and went to AC college. We didn't have any equipment here. So we went there, and then I checked NMR, mass spectrum and all those things, and found out it was a new compound. That fluorinone got cleaved and given hydroxyaldehyde. So we published that along with the mass spectral fragmentation pattern and everything in a couple of journals, and we got very good publications. So then what happened after I completed my PhD, then of course I got married at the time and I was teaching in Laila College also for a year. Then professor was going to US and he said, I'll look for any position for you. So I gave him my biodata and he met Professor H.C. Brown. He went to Purdue and he met Brown and gave my CV to him. And even before Professor returned, I got a letter from H.C. Brown asking me whether I can join him in December. So that was a great thing, and I was really, jumping. I didn't know what to do. So I accepted that offer, and I had to go in March. So in '79 March, I went and joined H.C. Brown, and that was also guided by Professor NVS because he has been guiding me throughout in my life, starting from MSc, PhD, and then postdoc. And again, coming back to India also, I worked with him in Ideal Chemicals for 6 years. So until such period, he was guiding me and mentoring. So then I went and joined H.C. Brown. So this is my preparation and growth. You can see here that my PhD with the NVS and postdoctoral fellowship with Professor H.C. Brown, 79 to 82. And in 1979, October, Brown got his Nobel Prize. So that was again a big story there. And suddenly on 8 o'clock, there was a call from Sweden, from the Nobel secretary, and said that H.C. Brown, he was awarded Nobel Prize. So we couldn't believe that. We thought it was a prank call or something. So later on, as the day advanced, it got confirmed that he got the Nobel Prize. And there was a big
Nobel Prize for the work done how long ago?
1940 to 1935, almost 40 years.
40 years, 4 decades later.
Yeah, he was 69 at that time, 67 at that time when he got his Nobel Prize. So we were there at that time, and that was a very beautiful moment for us, because everywhere we can go and say, see, Nobel laureate's student. So the whole department used to look at us like that. So we had a very good time, and that came in very handy for us because he got busy, so busy that he could not pay attention to our work. So we could do independently what we wanted to do. Otherwise, he will ask every time what you have done. So give some kind of instructions to do. So this time he was so busy, he left us, do whatever you want. And so for 1 year almost, he could not come to the office regularly. He was invited everywhere, all over the world. So then that was the time we developed our chemistry knowledge and all those things. And what I normally do is, so this is my career growth. So PhD, H.C. Brown, and industry, again in Brie, and where I had to start working on inorganic chemistry and perfumery chemicals, and then instrumentation, and then another industry where SPIC Science Foundation with Professor T.R. Govindachari, another big scientist in India, father of natural products in India. So such a great man. And he was principal of Presidency College also. So very many great people worked. They were students. Even NVS was a student with Professor Govindachari. So I had the opportunity to work with T.R. Govindachari. For 15 years I worked with him. And then I started the lab. That was, we had to do that one because I had 12 students at that time. And SPIC Science Foundation, they were shifting the lab, and all the students were thrown out. So they could not get accommodated in any of the other labs. So I took sympathy on that, and then I started this lab. And like Sanyasi Pune Avalata Madri, now I started this lab, and in order to have a platform for people to do research, that platform has to be recognized. So I had to apply to University of Madras and get the affiliation. So I got it. Second time I got the affiliation, and so people can do the research in our lab itself and submit the thesis. No need to go to any university department and all. So that was a big achievement.
So that was the year 80?
No, 2004. 2004. Just after I started the lab. So then a lot of things, I will come back to this. Okay. So the fusion of learning in each project, that is what I have been building up as my preparation. What did I do in 74 to 76 is kinetics, which is a reaction mechanism, and preparative TLC, as I told you, that one gave me some kind of idea about how the synthesis can be done. Now in 79 to 82, I went there and applied this kinetics knowledge to synthesis, which Brown's group people never did. All his students, when they do, even here also, when they do organic synthesis, they just take the reactants and put it in a flask and then allow it go overnight, or allow it to go for certain hours, 4 hours, 2 hours, or something like that. They never followed the reaction. So that requires kinetics knowledge or interest, so which they didn't do. With the result, what happened was, in 1950s, Dr. Subbarao, he was the student with Brown, and he did a reaction with sodium borohydride and aluminum chloride. You know, it will react and give boron generation, and that will go for hydroboration. But they were not knowing about boron generation at that time. But he was doing, see, Brown has got some 52 set of compounds, and he will start reacting each compound with that reagent. Any new reagent prepared, he will screen for all the 52 compounds. So that's how this person did for esters. When he did with one unsaturated ester, that is methyl oleate, oleic acid, you know oleic acid, C18 carbon. So that oleic acid methyl ester, when he was doing that one, the reaction was over very fast, and he didn't know, and it gave a gummy product. So he went and told Brown, sir, I'm getting a gummy product, it is not giving me proper results, I'm not getting the reduction product. So we will omit that compound and publish with the rest of the data. So Brown, he didn't want to leave it. He said, no, you do that, and then only we will publish. So when he did that, he found out that it was hydroborating. So later on, they started using sodium borohydride, aluminum chloride instead of diborane. Diborane is a gas actually. So using a gas for this, and that too, it is highly inflammable. So even if some boron leaks in the atmosphere, it will catch fire. So this is an alternative for using a diborane. So that is where the discovery came. He used aluminum chloride and sodium borohydride and did that reaction, and everything going on happy for the next 12 years. And when I went there, I did the same kind of reaction with lithium borohydride this time. And I followed the reaction, the same case. When I did with methyl oleate, reaction was over in 20 minutes. I didn't believe. I repeated 3-4 times. Then got confirmed by that it is reducing. So what is the difference between a saturated ester and an unsaturated ester? It's just a double bond. The double bond is also near the ester group. If it is near, we can say it is a cyclic effect or something like that. But it is isolated. That is undesinovate. I took the undesinoic acid. So that was end double bond. That also reduced faster. So then I found out that the hydroboration gives you an alkyl boron compound, and that acts as a catalyst for reduction. So that is how the one which took 7 hours, 8 hours normally was over in half an hour. So that kind of a catalysis I found out. Then I started making a number of novel catalysts, and then I published that one. And this is the difference, where I could use the kinetics knowledge, which helped me in discovering new catalysts. So then I came to India. I was there. I learned NMR, how to operate NMR, because in US nobody will do analysis for you. You have to do everything yourself, including nitrogen cylinder you want. You have to go to the stores and bring it yourself. Nobody will come. No attender will be there. So everything you should be prepared to do it yourself. So we had to learn all the equipments. That was a blessing in disguise. We learned NMR, IR, UV, everything available in the department we learned. So that helped me when I came back to India in 82, end of 82, and joined Professor NVS. That industry, Ideal Chemicals, where our former staff, B. Ganapati Sundaram, was also working in that company. And then when we joined, he left. The thing is, they were making an explosive product, ammonium nitrate explosive. And that ammonium nitrate explosive is a high explosive. So high explosive means that has to be triggered to explode. Otherwise, it will not explode. Ammonium nitrate in our labs, it doesn't explode. But it has to be triggered. So for that, you need a secondary explosive. And then a primary explosive. Primary explosive is like lead acid and things like that. Secondary explosive is a sensitizer. So for that, you need methyl ammonium nitrate was the product. And that was somebody, Atlas or some company, has taken a patent on that. Methyl ammonium nitrate as a secondary explosive. So these people, Ideal Chemicals people, wanted to circumvent that patent. So what they did, they used ammonium nitrate and formaldehyde. That reaction product, that is a Bloch reaction called, where it will react with ammonium nitrate to give you methyl ammonium nitrate, dimethyl ammonium nitrate, and trimethyl ammonium. So that is the sequence. So you stop it at methyl ammonium nitrate and use it. It will be similar, but you are not infringing the patent. So that reaction, unfortunately, they were not getting pure methyl ammonium nitrate. It always goes to the extended reaction. So secondary amine nitrate also was formed. So how do you analyze this molecule? How do you follow this reaction? It is an aqueous solution. Ammonium nitrate formaldehyde reaction is the aqueous medium. So which technique you will use to find out how the reaction is going? That's where I got this NMR. I went in for carbon NMR. Proton NMR is very difficult because you will be using a lot of water. That itself will mask all the signals. So you take carbon NMR, all protons will not show up. Only carbons will be seen. So when I do that, simply I was really surprised to see that even formaldehyde solution, how many carbons are there in formaldehyde? 1 carbon. So how many signals you should get in C13? Carbon 13 NMR. How many peaks you will get? 1 peak, right? But I got about a dozen peaks. Like that. So you have to interpret why formaldehyde is giving so many peaks. You know, CHO. What happens to CHO when you add water? It will become CH2OH, OH. Okay, CH2O is your formaldehyde. When you add water, it becomes CH2OH, OH. That is hydration. So in our BSc classes and all, they will say 2 hydroxy groups on same carbon atom is unstable. It will immediately dehydrate and give you the aldehyde, right? That's what we were taught. But you put it in water, this formaldehyde, it will always exist in hydrated form only. And not only hydrated form, this will start condensing with each other, intermolecular, and formaldehyde monomer, dimer, trimer, and sometimes this trimer will be in the cyclic form. So all these kinds of species are formed in formaldehyde solution. So what happened? We just put the ammonium nitrate there and checked. All that collapsed and only 2 peaks we got, which were like methylamines, that is NH2, CH2OH, CH2OH, like that. So from there we could stabilize the reaction conditions for making monomethyl ammonium nitrate. So that helped the company, and we did that on a small scale, 100-gram scale. But they immediately scaled it up to ton scale. They did it in ton scale and they got excellent results. So that was transforming your knowledge in instrument to chemistry. See, where is organic synthesis and where is ammonium nitrate? Far away. It is demarcating your career line. But still, you know, we could get in there and start contributing to that institution. So then I realized your instrumentation knowledge is very, very important for carrying out your studies, further studies or research or anything. So then 82 to 88 we did our NMR, I told you, and quantitative NMR also. We did a lot of quantitative studies with NMR, especially carbon NMR. Carbon NMR quantitative study is somewhat difficult. I don't know how much of you know about the NOE, nuclear overizer effect. Nobody knows, right? So I don't want to dwell with all those terminologies here. But doing quantitative NMR with proton is easy, but not with carbon. So we developed the technique to use carbon NMR also for quantifications. So then from 88 to 2003, 15 years, I was going with Professor Govindachari, working on natural products. And there, what was the problem is the natural products people, they have one set of procedure for extraction. So what he did, we started looking at neem, pepamaram. So he brought that neem kernel, வேப்பங்கொட்டை அந்த பருப்பு இருக்கு இல்லையா அந்த கர்னல் அதை கொண்டாந்து he used to put about 10 kilos of this neem kernel and put about 50-60 liters of hexane and leave it, and we did that in CLRI. So leave it for 1 week to soak and again remove that, again add one more lot, twice, 3 times. So 3 times they will extract the kernel with hexane, and it used to take how many days now? Almost 3 weeks, and then you will have to evaporate them and get the product. Now that way you cannot, if you want to transfer this to an industry, do you think that industry will have the time to wait for 1 month to get 1 batch? So we need to reduce the time. So I started looking at various other altered conditions and all, and found out a simple way which will be over in about 2-3 hours, and you will get the extract. So that is the development we made, and then I formulated that and made neem gold. We call that neem gold, and that worked out as a very good antefeedant. Antefeedant means, feedant means eating. Okay, antefeedant. It is deterring insects from eating the crop or pest. I mean the crops and leaves and other things. So that's an antefeedant product. So we developed all those things during that time. And from 2003, as I told you, I have started this Asthagiri, and the background behind that starting is to help the students. And we started working on herbal chemistry. And during my days in this period with the Spic Science Foundation, we started working on various projects. One is synthesis, agrochemicals synthesis and also I was a PhD guide at the time, and into a niche area like pheromones. If I don't talk like pheromones, talk on pheromones, my lecture is not complete. So pheromones, what are pheromones? Anybody know? Have you studied in any of your ancillary zoology or something?
It is produced by an insect.
Yes. It is a chemical cue given by the insect. The female insect will release that chemical and the male insect will sense that. And it will approach the female and mate and then propagate. That is how the pest population increases in various agricultural crops. So now what the chemistry is here, you will have to isolate and identify this for me? No need at all. Anyway, that's okay. That's always there. Madras weather. So, thank you anyway. So that chemical, you will have to isolate, identify what that chemical is. So what are all the techniques you need for that? Extraction, purification, and then spectral studies to identify the chemical. So once you identify, then comes synthesis. So you have to synthesize because you can't extract the chemical from the insects. You need lakhs of insects to get a few grams of the chemical. That is not enough for using it in the field. So you have to synthesize that. So the synthetic chemistry comes into picture. Happy to say that one of the students from here, Vivekananda College, he joined me in '91 as a student, PhD student. He did an excellent job. In almost he synthesized about 15-20 pheromones. 20 pheromones during his thing. Very meticulous and very systematic worker. He took 6 years. Normally I don't like people to work so long. I want to finish that fast and let them go. But he was so systematic that he took so much time, and his thesis is even now you can see so big in my lab. And I sometimes use that as a reference one for doing the pheromone synthesis. So it's a very, very challenging field. And now one of the person in Hyderabad, he has taken it up because this pheromone is a eco-friendly product. That is, there is no pesticide or anything involved. It controls the application of pesticides. So therefore, this is a very important project, and DBT has sponsored quite a lot. Even for us, they have sponsored a lot of money to develop pheromones. Pheromones for various insects, and even I'll show you here. So these are all the semiochemicals. This is one of the. This is a pheromone for capturing house flies, Musca domestica. So you put the pheromone inside, everything will come and go inside and trapped. And this we used in horse studs and also in poultries, where all these flies will come and get captured. And at one stage, you cannot count the number of flies caught. You have to weigh the bucket, see how much house flies were caught. So that is the kind of technology.
So
and
bees getting attracted to the pollen.
Which one?
Same phenomenon.
Which one?
The bees.
Yeah.
Honey bees getting attracted to the pollen.
Yeah.
This is the same phenomenon.
That pollen will have certain chemical, and that is what will be attracting. Now they have found out that it is methyl eugenol, which attracts the fruit flies. So when you keep that methyl eugenol in the field, you can see all these fruit flies will come there. And that is one way to control fruit flies in the mango orchards. So that also my collaborator in Hyderabad has developed a large number of this kind of pheromones, and he has prepared them in tons. We were struggling to make them in grams. He has made them in kilos, tons. and he is recognized as a leader in this field, and recently he has been given the award from FICCI or some body there in Hyderabad. They gave him an award for this. So, well, this one is in a tea estate. Here again, the volatile chemicals from the tea leaf will attract the tea mosquito. That will come and puncture the leaves. So tea leaves, can you apply pesticide? What will happen?
Poisoning.
It will poison, and you cannot take that kind of a leaf. I mean, this is directly we take the tea leaf for our drink. Now this will be a very ideal technology to control the tea mosquitoes. So I told my collaborator in Valparai and asked him, this is a baffle here. I told him, he kept one funnel, and I told him, see, instead of one funnel, keep many funnels. I meant one here, one here, one here, like that, a number of traps. But what he did, put one over the other and made it like this. So that's why he said miscommunication. So this is me.
So does this work in domestic environment?
It is in the field.
Not in domestic.
Domestic, you don't get that kind of...
Mosquitoes.
No, tea mosquitoes.
Oh, tea mosquitoes.
Tea mosquito is different. So this is household mosquitoes. So likewise for many crops, this is for sugarcane early shoot borer, you can see that one. And there will be so many dead hearts from the sugarcane field. Now, if you apply the pheromone which we synthesized and we went to the field, we checked our product and we found that it was controlling the pest. So we developed a probability theory there and then found out you can do mating disruption. Mating disruption means you disrupt the mating or mating of this male and female using your pheromone. So that way you can control the population. So we developed all those things there. So this is for mango. You can see the mango nut weevil. Mangoes are very sweet. But the moment you cut it, this guy will start coming out. So this mango nut weevil is a very major pest. The moment you send, you can't export the product. When I export any of our mangoes, people are averse to buy, mainly because of the insect presence. So how do you control this one? We worked out on the hue from the mango surface, the skin of the mango. We took that one and we did a lot of TLC studies, and then see, we found out finally that it contained palmitic acid. The surface of the mango contained palmitic acid which attracted this insect. So it is a ovipositor. Actually, it is not a sex pheromone. It is a ovipositor. Ovipositor means it will go and lay eggs. It needs a location for the insect to go and lay eggs. So it searches for that, and this is the chemical that gives it. So that we identified, and in a resistant variety, we just went and applied this chemical. We could see that bug, that comes and lays laying egg. So that's what here I have shown. It's laying egg here. So what I mean to say is chemistry has got a lot of applications, and this is one is allelochemical. So this is aloe vera juice, bioremediation we call it. What's the time now, sir? I can.
5 minutes to 2.
Yeah, I will finish it off in 5 minutes. So I will go to all those things. You see, a lot of opportunities and things like that. And this is, I have gone through various areas like entomology, microbiology, biotechnology, and so many different areas, and where chemistry is applied. So I don't do biotechnology, I do chemistry in biotechnology. You get the difference there, okay? So entomology also, the chemistry of the chemicals released by the insect. That's what we are identifying. we are not talking about the insect. We are talking of the behavior of the insect using chemicals. So it's all there, and this is an endophyte. Rajagopal here has been collaborating with me on this endophytes, and of course Suri is the master of this one.
Chemistry.
Yeah. Not chemistry, botany. He was collaborating with me in those days, and Suri, of course. And this endophytes has got a lot of interesting factors. And this endophyte from neem has got a property. One of my students was working on that, and now she has got a big industry she has started working on. She has started her own industry. This endophyte, she was making this endophyte, and my other colleague was developing culturing insects. And he came one day with a very angry face. He said, "Sir, ask her to stop that. All that is killing my insect." So then I found out that the endophyte from this one is going and colonizing on that insect. So it is an entomopathogen. So it was developing an entomopathogen which is controlling the pest which this fellow was culturing. So because they were all just opposite, very nearby places. So
It's accidental discovery.
it's accident discovery of that. So these are the various areas where you can work. Now a few employees, this is what courtesy our Vivekam group. There I just picked up, they are releasing all advertisements from various companies for jobs. So what is that they are asking for? See, look, quality control, officer, executive, raw material stability, HPLC, QC, GC, all these things they want. How much you know? Can you apply for this position? Right? So this one, we are hiring, location, Hyderabad, MSc in organic chemistry, expertise in organic synthesis. How much of synthesis you can do? What are all the reaction setups you know? Dean-stock apparatus, you know what is Dean-stock apparatus? How many of you know? Do you know what is Dean-stock apparatus?
Green star.
Dean-stock. Dean-stock. Terima pa? Sock slit extraction? Terima? See, what I am telling is, people even don't know what the glasswares are. What are the glasswares we have? How it is all used, for what purpose? So these things you don't know, then how can you get into a job? By releasing this kind of advertisements to our group, what is the use of this for our students? You can see, there is a lot of opportunities, that is all. But how will you get in there? Unless you know these things. They are requiring. These are all the advertisements, requirements from the companies.
It's a graduated team with a 20 class.
Sir, you don't. That's right. It's for the students. So what I am telling is, there is a lot of opportunities available in different industries. Quality control. What is required for a quality control person? It is all the instrument knowledge. And more than that, it is not just operation of the instrument. It is reproducibility, repeatability, validity, validation of a method. Lot of things will come in. Only then you can go in your career up. You can become a quality manager, quality analyst, quality manager, general manager, like that. You can go up. But without having all those skills, you cannot do. At least I don't expect you to know everything at this stage, but at least how to handle the equipment. What are all, at least theoretically know what can be done. What you should do if you want to give, say, a method is validated. See, why I am telling this, you are all doing titrations here, right? How many of you get the same result, exact result? Not the one which attender tells you.
So you have to get 2 consecutive times, right?
That is one thing, sir. But how many people get the same value? Statistically, if you look at it, it will vary. So precision and accuracy, right? So how to bring down that gap between each one of you doing that study? So only then you are doing perfect job, right? So there is inter-lab comparison, intra-lab comparison, and so many things are there. Proficiency testing, all these kinds of things are there for an analytical chemist. If you want to be an analytical chemist, you need to do all those things. Apart from learning how to do chemistry, how to handle equipments, you have to do all those things. Synthesis, you need to know the equipments, assemblies, nitrogen atmosphere reaction. Why should we do that? Moisture, avoiding moisture and doing it. How? So all those things are to be learned. You can't learn it in one day or just by looking at it. You have to have the practice. The college cannot give all this practice by themselves because they have a mandate. They have to complete the study, the portions, and also experiments. They have certain things. They have to do that. So I cannot blame the authorities or the department for that purpose. We were all grew up like this only. But you need to have that kind of preparation. You need to prepare. Nowadays, things are available. In those days, it was not available. So now it is available. You can go and learn. Touching the equipment. How many of you have touched balance? Electronic balance? You have an electronic balance? How do you weigh? சொல்லுப்பா எப்படி வெயிட் எடுப்ப ஒன்னதான் வெயிட் எல்லாம் எப்படிப்பா எடுக்கிறீங்க ஓகே ஃபைன் தட்ஸ் ஆல் ரைட் ஸோ அந்த வெயிட் எடுக்கிறதுலேருந்து people don't know. When I take a fresher, I have to train them on all those things. Starting from taking weight, assembling the apparatus, so many things we have to do. So that skill development for various jobs, that is what is required, and you will have to look at it. For researcher, it is only passion and curiosity. And pharma, you need to know synthesis, skills in synthesis, interpretation of data, whatever you are getting. I can keep on talking, but we don't have much time now. Chromatography is a very, very powerful tool. You can start from thin layer chromatography to column chromatography, then flash chromatography, then GC, HPLC, HPTLC. There's another powerful technique. So all those things are there, and if you want to go as an analytical chemist, analytical analyst, and go to QC, QA, then you need to build up all these skills for you. Okay, so from university to industry, bridging the gap. You need to bridge the gap. So that is the role our lab is doing. We have been training students for industry preparedness. So this is the student project, and on all those areas we give the training. On a project mode also, where you can publish the paper. So thank you for the opportunity, and I have to salute my professor here, and I'm very fortunate to give the first lecture in this hall named after my teacher and guide. Thank you very much for the opportunity.